So we're continuing section 2.2, and so far we've graphed in vertex form, we've graphed in standard form, and there's one last form, which is called intercept form, where this is your intercept form, where A actually is the same A that we see in standard form and in vertex form. So the same rule applies for whether A is positive or negative. If A is positive, then the parabola will be opening up. And if it's negative, then it will be opening down. P and Q are our x-intercepts. So P and Q are x-intercepts. Remember what that means is it's where it crosses the x-axis. So the ordered pairs in which they cross on the x-axis is going to be P0 and Q0. The reason why it's 0 is because any number or any y value on the x-axis, let's visualize this. Let's say that I have something that looks like a line. Let's try to make it more U-shaped. There and there. So let's say it crosses right here. So on the x-axis, y is always 0. This is a recurring theme that pops up all throughout Algebra 2, is when we're looking at functions, one of the points that we'll be, or one of the areas that we'll be focusing on, no matter if we're looking at a quadratic function like we will today, or a cubic function, or any sort of other polynomial function in the future, is that we're going to be focused a lot of times on where it crosses the x-axis. And where it crosses the x-axis is where y is 0. You also can call them zeros of a function. Just a little bit of vocabulary. We'll talk about that more in detail later. But today we're just focusing on parabolas. And when you have the x-intercepts, the only other point that you need is the vertex. So to find the x value of the vertex, you can see it in this picture in particular, but it doesn't actually matter where our x-intercepts are. They are the vertex, since our parabolas are symmetric, the vertex, the x value of the vertex is going to be an equal distance away from your x-intercept. Okay, so if you think about if it's halfway in between, if the horizontal distance of the x value of your vertex is halfway in between your intercepts, then it makes sense that to find the x value of your vertex, and this is x value of vertex, and this is an important formula that you'll want to write down, is x equals p plus q divided by 2. It's essentially a midpoint formula, but what you're focusing on is the x value of the vertex, because when you find the x value of the vertex, you can plug in and solve for y. So to find y value of vertex, plug x value of vertex into function. And I'm okay with 3 points: the vertex, the x-intercepts. And that is usually going to be enough for you to get a good idea of what your graph looks like. So let's find, no, I'll have to scroll down, actually. Oh, that's good. So let's graph f of x equals -2 x plus 3 and x minus 1. So based off of what we know, P is, so again, recall the formula that it's minus P and minus Q, opposite of P and opposite of Q. So P is -3, Q is negative, or Q is 1. So the ordered pairs are going to be -3, 0, and 1, 0. And if we graph those, 1, 2, 3, and 1. Now, you might be able to visually see where the x value of the vertex is. So you can use the formula or count halfway in between. So it's going to be 1, 2, 1, 2. So the x value of the vertex has to be at -1. But if you use -3 plus 1 over 2, that's going to be -2 over 2, which is -1. Then plug that in for x, and that'll give you the y value. And you do need to know where that, what that y value is, because you don't know if your vertex is here or here. We do know that it's going to be above, though, because the parabola should be upside down. So plugging in -1, we get -2,
Hey,
2,
I'm all wet now.
-2. And so that's going to be 4, +8. So all the way up here. I'm going to scale this by 2s. 2. And there's our parabola. Okay, now if you scaled it by 1s, yours will be up, much narrower. But yep, that's how you graph an intercept form.